I know. Yeah, I'll be back there. We're right here.
All right. So my name is Gavan Wilhite, and I'm here from AltspaceVR, and I'm going to talk to you guys today about constructing the social VR web. So the main parts of this talk are going to be explaining a little bit about why we care and work on the VR web, a little bit about how our browser works, and look into some of the new technologies that we've been building over the last few months. So a little bit about Altspace. So Altspace is a social VR platform. You basically put a VR headset on, and you can be in there with anybody, anywhere around the world. And you could go into that for large comedy shows or to do an office meeting. We hold a lot of our stand-up meetings in there. You can go in there and you can play games and use applications with other people. The main thing I'll be talking about today is those applications, because those are all built on the web using an SDK that we built and a browser that's inside of Altspace. So Altspace works across many different platforms. All the headsets that you see up here, all the different operating systems. One of the important things is that it works on all those mobile devices, right? So Gear VR and Daydream. It also supports a lot of different peripherals. So no matter basically what you plug in to Altspace, it'll be read by the system and we'll fuse it into a single unified input system and tracking skill. This is really useful if you're building applications because you don't necessarily want to know how Altspace knows where your hand is. You just want to know where the user's hand is. This also involves a lot of people. There's over 150 different countries who use Altspace on a regular basis. At our live events, we'll have thousands of people in the audience at the same time. And one of the really nice things, especially for the developer community, is that people in Altspace almost always have access to really high quality VR. And they're in that VR device when they're seeing your application. So we found ourselves in the place where we have this really great social platform where you can be there and you can talk and you can laugh and you can discuss and you can do all these great things. But people wanted to be able to do more things. They wanted to do things together. And they wanted to do this across all platforms and instantly and safely. And really what that meant is that they wanted the web. And when we started looking at this was like 3 years ago, and there wasn't really any development here, so we were trying to figure out how can we do this in the best way. And so before we go any further, I just want to give you a little bit of a sneak peek about what this ends up looking like, these applications. So this is one of our most popular games. This is called Holograms Against Humanity. And it's essentially a version of Cards Against Humanity that people built for VR. And so this is great because it encourages people to laugh, they'll get in there, they'll make friends. And we had 5,000 games played last month. It's also open source, you can find it on GitHub. So a little bit about how things like Holograms Against Humanity works in Altspace. So what we did is we built a VR web browser. And the way that we think about this is with a traditional browser, you have an application shell, where if you imagine like Chrome, you have the title bar, the URL bar, the preferences, all that kind of stuff for sort of the main application. Then you have this browser engine that's rendering everything that's inside of the frame, right? And with a VR browser, we think that you need one more thing, which is a game engine. Because anybody who's built VR applications or games knows that you really need access to all the technology that game engines have been building for the last 20 or 30 years. You want access to the audio spatialization, to the physics, to the networking, to the asset content pipelines. And so we built this, and then we built an SDK around it to make it easy to use. When we think about these VR browsers, we see sort of two main paths forward. So there's this nice shiny thing called the VR web, or whatever you want to call it, that we're all shooting for. And we can imagine what that's going to look like in 3, 5 years. And I see there being two main paths, and I think these are going to happen simultaneously, where there's going to be these traditional browsers, sort of the Chromes and Firefoxes on the desktop. They're going to have these very low-level VR APIs, things that look similar to what we currently have as sort of web VR APIs. And then we're going to have this other class of browsers that are coming out that have these game engines built into them. And those are going to have these high-level VR APIs that are more traditionally consistent with how we would expect the DOM to work at. So a little bit about how we made our browser happen. So yeah, this is essentially the stack that the web application is running in. So we have sort of the main web app up there. That's running on top of A-Frame or 3JS. This is then running inside of a Chrome Chromium-based browser we have in Altspace, which is running inside Altspace, which is then running inside of Unity. So Unity is our gaming engine, and Chromium is our browser engine. What we did to make this work inside of Altspace so you could see this content is we built our own 3JS renderer. So one of the nice things about 3JS, and 3JS is basically this open graphics platform for JavaScript, is that it's render agnostic. When it was built first, WebGL wasn't actually around yet, and so they built it so they could render directly to 2D canvas or to DOM elements. But what we did is we made it render to Unity objects, essentially. So when the render call comes in, we copy that scene graph across the wire, and we're able to re-represent it in our gaming engine. And so right now we support sort of a subset of 3JS specifically targeted for performance, but we're expanding that every day. We also added some core JavaScript APIs to make this easy to use. So this is getting things like the tracking skeleton of the user, getting gamepads, very much like how you would get it with a traditional browser, but we also added new types of gamepads, including 6DoF devices. So with the SDK, you can make these apps and games that live on the web, right? That's really important. You're hosting them at any URL. You can use GitHub Pages, you can use your own server, you can do AWS, you can use any backend. And one of the things that's really important is that there's no gatekeepers here. With every other type of VR application other than the VR web right now, someone has a storefront and they're telling you what you can and cannot put in there. The web is really successful because there is no gatekeepers. People can put up whatever type of content that they want, and they don't have to ask anybody for permission. When you're also making applications with this, it's nice because you're inside of Altspace, and so you have access to all the things that you would expect in Altspace. So you have access to the voice over IP, so people can talk while they're using your games. You have access to events, so people can schedule times to do these things. And we already are providing avatars and environments, so you don't have to build that in if you don't want to. When we think about these, we think of two different types of applications. So one are these enclosed applications, and these other ones are full space applications. And this is very analogous to if you think about having a windowed application, like a windowed web page, or a full screen web page. Enclosed applications are interesting. So they're basically defined where normally you'd have a 2D browser window. You could sort of imagine scaling it, right? With the enclosure, you have this 3D browser window. And the interesting thing about this one is that these should be sort of forward compatible for AR as well when that finally comes around. Because you can easily imagine both sort of setting this on a desktop in VR or setting this on a desktop in AR. Full space applications, this is a newer one for us, but this allows you to make these really large applications that cover an entire space. So another example here before we go on. So this is one of my favorite sort of educational apps that's in there right now. It allows you to do protein visualization. And this is loading live from a web resource, but basically you can spawn these three-dimensional proteins. And the nice thing is that because it's an Altspace, people have held events in here where you'll have one person who's using like a leap motion hand and indicating to parts of the protein, and everybody else can watch them and sort of attend the lecture and ask questions at the same time. So the question is, what's next, right? So we've got this core thing. You can build these applications like Holograms Against Humanity, like AltPDB. But it's not the easiest thing to do. You need to know how to write good 3JS code. You need to have some background in computer graphics. But what we want is we want something that's a little bit more like the web normally is, where you can write a few lines of HTML and get something really compelling. So the 2D web had this going back a long ways. In the very beginning of the 2D web, we started with these things like text area and image tags. And we don't often think about it like this, but these are just sort of these native elements, these native components, these buildings that we needed to have a compelling 2D web. And so the question is, what are the equivalents for the VR web, and how do we build it? So our answer, at least for the moment, is A-frame native components. So this is something that's been in for a few months, and we're finally releasing it. And this is basically piggybacking on top of a really awesome framework that Mozilla has built. And I'll tell you a little bit more about it in a second. But there's a more important question here, once I can make this full screen. Which is, why is Brian on fire? So this is showing off a few different native components that we have, and I'll slowly explain why some of the more ridiculous things are going on in here. But you can see he's pulling a basketball out of his chest, and he has all these crazy fire effects. So A-frame is basically built on 3JS, so we're able to leverage our existing 3JS renderer. And it has this really nice entity component system model. And so this is something that you would expect coming from the gaming world. So Unity basically has a very similar concept to this. And it allows you to use that in the browser for the first time, which is really powerful. It's almost a little frustrating to me that in the 2D web we haven't had this model up until now, because it's a very easy way of doing programming. So what native components look like in practice is this is sort of a line of A-frame. And this is basically saying, this is sort of how you get that basketball in Brian's chest here. It's saying, I want an entity here, and I want it positioned at a certain place, and then I want to create this native spawner, which is one of the native components that we have, where I want this basketball to be placed in. Right? And so these look and function exactly like A-frame components. They have the same schemas, etc. But they're implemented by our browser rather than in JavaScript. This allows you to directly access game engine features. It also allows us to expose some of our infrastructure for people to use. So that'll be things like networking or physics or audio. So these are some of the native components that have been out there in beta. We have text, object spawner, collider, container, sound, and skeleton. So I'll be explaining some of the different ones here and showing you some example applications on how they're being used. So text was one of the first ones that we built. And this is really important because it's actually pretty hard to get good text in 3D. Oftentimes you're trying to use geometry or you're trying to use textures, and it either gets really fuzzy when you get up close, or it's not very performant. And so we implemented it with signed distance fields, and that allows you to make this really crisp, nice text. And so one of the applications that we have in our lobby is this conversation starting app, where you can sort of meet people and you have these prompts. And so we did this thing running on the background, especially on Gear VR, not consuming any resources, and the signed distance field text works really well for that. Native objects are really useful. So this allows us to pull, you can basically have a sort of like internal URL syntax for defining different types of objects you want to pull from existing resource libraries that we're providing. And what we figured out was that one of the hardest things for people to do when they're building these applications is get good 3D assets. Because even if people are artists, making performant assets for mobile VR is difficult. And trying to download them from online stores, you can do it, but trying to get them converted, it's just a really big challenge. And so we're trying to provide a lot of these packs of resources to get people up off the ground. You know, they can use, obviously, their own custom models, but getting something started is really useful. This also allows us to start adding things like particle effects before we have sort of full systems that enable full customization like that. So that is one of the reasons why Brian is on fire, is because he has these native particle effects on him that are being pulled in from the native object component. So this is I'm actually pretty proud of. We built our poster in the SDK. And so if you come over to our booth, you can see this, and we have the source code sitting next to it. And it was one of these things where we were trying to figure out how to do it, but it ended up working out really well. And what we did is we actually just literally sent a screenshot from the game engine over to the printer. It was a 12K resolution screenshot that we shot in super resolution. And it actually goes to show the effectiveness of the text component, because you can walk up to the poster, the text is perfectly crisp, just how you would want on sort of a print file format. So that's kind of fun. Come by and check it out. You can also pick up, if you ever play Cards Against Humanity, we printed out a bunch of Against Humanity cards from users that have submitted it for our online game. And so they have a lot of fun VR references. I think Palmer Lucky's Flip Flops is one of the cards in there. So you can come by the booth and pick up with that. So spawners are fun. These were the basketballs that you saw being pulled out there. One of the basically allows you to, we were trying to figure out a good way of letting people do physics, but doing distributed physics is actually very, very challenging. And especially exposing it in a way that is use case agnostic, where anybody can use it for anything. So we decided to go sort of simple first and make this atomic component where you can create these spawners that people can pull these physical objects out of, and then they're natively synchronized to everybody else in the room, so that's going over our game infrastructure. And people are able to do easy ownership transfer and things like that.
May I have your attention, please? May I have your attention, please? A fire has been reported in the building. A fire has been reported in the building.
It wasn't Brian.
Please proceed to the stairways and exit the building. Do not use the elevators. May I have your attention, please? May I have your attention, please? A fire has been reported in the A fire has been reported in the building. Please proceed to the stairways and exit the building.
All right. I don't think that was planned. Everybody's pretty quiet, so I'm sure it's nothing, but we have to
May I have your attention,
stop the
please?
session.
May
So
I
I'm going to
have
stop
your
the live.
attention, please? A fire has been reported
Check out my
in the
page to
building.
see what's
A
coming
fire
up next.
has been reported
Bye.
in the building.